The water you just drank is more than 4.6 billion years old. Not only that, but also the water that you use to cleanse your face, cook your food, and wash your clothes is older than the Earth itself. No, I'm not joking. Today, about 70% of the Earth's surface is covered with water. The Earth is the only place in the entire solar system where you can find such colossal water reservoirs on the surface. But have you ever wondered, how did water appear on Earth? Was water always part of our planet, or did it come from somewhere else in the universe? These are the questions we often think about while having this tasteless, yet most essential beverage. To learn about the origin of water, let's go way back in time. When the universe began 14 billion years ago, there were just 3 chemical elements that were formed: hydrogen, helium, and lithium. Just like every compound, even a water molecule is made up of simple elements. 2 hydrogen atoms and 1 oxygen atom make up a water molecule. So moments after the Big Bang, we had hydrogen. But what about oxygen? Okay, stay with me. About 400 million years after the Big Bang, the first stars lit up the dark universe. These stars were primarily made up of hydrogen and helium. As the massive stars evolved, they fused heavier elements in their core, and one of them was oxygen. Are you still there? When these stars imploded, they enriched the interstellar medium with these heavy elements. Eventually, when temperature and pressure permitted, the newly formed oxygen atoms combined with the hydrogen to create water. That's how the universe got its first water molecules. But the question remains, that how did water appear on the Earth? Well, the dying stars scattered the heavy elements in space, and from those elements, planetary systems formed. Ours is one of them. But if you look at the early solar system, the Earth formed too close to the Sun. Water could not have been incorporated into the rocks as ice or liquid. So why does Earth have so much water? One of the most widely accepted theories says that water actually got delivered to Earth after its formation by the hydrated asteroids. These asteroids formed away enough from the Sun to contain water ice. And then this ice got transported to Earth when collisions between these rocks and our planet took place. It is believed that Earth interacted with various icy planetesimals about 4.5 billion years ago and was able to retain water in some significant impact events. So that's a theory. Do we have any evidence to prove it? Is there any way we can confirm this hypothesis? Yes, and it's an interesting one. For that, first let me introduce you to the heavier cousin of hydrogen, the deuterium. A typical hydrogen nucleus contains a single proton. Deuterium has a proton and a neutron. This extra neutron makes deuterium isotope twice as heavy as hydrogen. Just like hydrogen, deuterium formed only in the early universe. When astronomers study the ratio of deuterium to hydrogen, or the D to H ratio, they found that this ratio in the Earth's water is almost equal to that in asteroids. 4.5 billion years old meteorites found on Earth further support this claim. But when they calculated this ratio in comets, such as the famous Halley's Comet, they saw that it's twice that of the oceanic water. This shows that a large proportion of water on Earth came from asteroids rather than comets. Besides that, it's also believed that hydrogen inside Earth might have played a crucial role in forming water on the planet. These two theories are entirely independent of each other and are the leading ones to explain the origin of the water. But if they are authentic, then why don't other planets have water? If the Earth witnessed asteroid impacts, weren't they seen by other planets as well? So why does only the Earth have such vast reservoirs of water? Well, that's a question for another episode of the Ever Wondered series. Share this video with your friends and make sure to follow our page for more such thought-provoking videos.